create the problem and we will do the troubleshooting also. So I will take 2 router. Okay, I am taking 2 router. 2 router is enough, or if you want you can take 3 router, that is up to you. Here I can take 2 router, and if you need I can take the dummy switch here in between, and or I can take this switch in between here, and then I can connect some router here also. If you want we can connect some more router here. So now you have R1, you have R2, and then you have switch, you have the R3 and R4 here. Then you can connect from here to here. You can click here so you can see the interface name. 2 router is also sufficient for us, but anyhow I am connecting here this topology like this, and here I am connecting this one. And now we can move this port here so we can see what are the ports we have. Okay, this is the ports and we have the routers. So now I can power on the router and the devices, everything I power on here. Now whatever IP schema you are using you can write here. I will use here 192.168.12.0/24 here in between, and here we will use like 192.168.23.0/24. So this side we will use 23.1, 23.2, 23.3, like this we can use. Like here we can configure 23.2, and I will duplicate. I will configure here as a 23.3. Okay, first we will enable the OSPF, then we will do the troubleshooting and we will create the problem. So I will take the console of this R1. This is the console of R1. I will take the console of R2 also. Switch, we will not do any configuration inside the switch, so no need to take the console of switch, and I will take the console of R3 and R4. So now what I can do here, this is the CLI. We can move this here and we can do the configuration. I am in the R1. I can do the configuration here. Like first I will go in the global configuration mode, and then I need to assign the IP. So I will write interface F0/0 IP address 192.168.12.1, give space 255.255.255.0, and we will write no shut. I assign the IP address to one interface here. And now I need to enable the OSPF, so I will write router OSPF1, and I will use the interface method. If you want to configure the OSPF by using interface method, you need to write int F0/0. You will go under this interface and then you will write IP OSPF1, because I am using the process ID 1. So whatever the process ID we are using, we need to write here that one. Process ID 1 area, then after that area. What area we are using? We are using area 0. This all we are using area 0 here everywhere. So we can say this all we are using as a area 0. So here we can say this all are area 0. Here we have option to raise the lower. Okay, so this all area will be area 0. We are using area 0 here. So now if you see in R1 configuration is done, I can save the configuration here. I need to go to R2 and I need to do the configuration in R2 also. So I need to assign the IP address to the R2 also. So what I can do here, I can go and I can assign the IP to R2 also. So first I will go in the global configuration mode, then I will write interface F0/0, this interface IP address 192.168.12.2, give space 255.255.255.0, and we will write no shut here. And we have one more interface, so I will assign the IP to that interface also, interface 1/0, IP address 192.168.23.1, give space 255.255.255.0, and we will write no shut here. After that we can enable the OSPF here also. So I will write router OSPF1, then I will use the interface method. Interface method means you will write interface F0/0. This is the interface, so I will write here IP OSPF1 area 0. Then you have another interface, I will write interface F1/0. I will write IP OSPF1 area OSPF1 area 0. And now I enable the OSPF here, this side in the R2, both the side. Now I need to do to R3, so I will go here, I will do for R3 also. In this one I need to configure, so I will go to the global configuration mode, I will go to the interface F0/0 here, and then I will put IP address 192.168.23.2, give space 255.255.255.0, and we will write here no shut. Okay, and now we need to configure OSPF, so I will write router OSPF1, then we have interface F0/0. I will write here IP OSPF1 area 0. So I enable the OSPF in the R3. I can save here, and I can go to the R4 and I can do the configuration in R4 also. So here in the R4 I can go, I will write interface F0/0. I will assign IP address. We will plan to use 192.168.23.3, give space 255.255.255.0, and we will write no shut. I assign the IP to the R4 also. Whatever IP we wrote here, we assign that IP. Now what I can do, I can configure the OSPF, so I will write router OSPF1, then I will use interface method F0/0. I will write here IP OSPF1 area 0. So we enable the OSPF here also. Now after some time you can check, all routes will come, everything will work perfectly. So here if I write show IP route, you can see I am getting this 23.network. This one I am receiving from this side. So I am learning the route from the OSPF. Okay. So now if I create any problem here, then we will have the issue. And if I go here, I can go to this router, like I can go to R4. If I write here show IP route, you can see I am getting this route 12.0. If anyone want to go to 12.0 network, they need to forward the traffic here 23.1, this one. So now if I change anything, example I will go to R4, we can see, or I can create loopback also, so that will be more easy for us to understand this concept. I will create one loopback here. I can write interface loopback 0, and we will write 1.1.1.1. okay, this is a loopback we are going to use in the R1. So I am going to configure here loopback, interface loopback 0, IP address 1.1.1.1, give space 255.0.0.0, and we need to enable the OSPF, so we will write IP OSPF1 area 0. We enable the OSPF in the loopback. I save the configuration. After some time you will get the loopback entry also here If you check show IP route, you will get that information. You can see R2 is learning this with loopback. Loopback R2 is learning this route, that is loopback route 1.1.1. Now they have the neighborship. So what we told, whenever we are doing the OSPF, if directly connected should be in the same area. If you change area here or here, then neighborship will go down. So let's see that one. So what I will do here, I am here in the R2. So I will go in the command prompt. I will go here in the global configuration mode. Then I will go to this interface. I will change the area. So interface F0 by 0. After that IP OSPF 1 area 0 we have. So I will make area 1. I change the area here, and you can see here neighborship go down here. If you see here what error we are getting, here we are getting that one when I put the, so in real environment also, if you do misconfiguration, you will have this issue, OSPF will not form. So here you can see the warning, you are getting the messages also, area mismatch. If you get this type of error, they are asking you to do the virtual link. We can use the virtual link if you don't have the area 0. So here, as I told before, when you are configuring the OSPF, this side and this side, both sides should have the same area, directly connected should have same area. Here we configure area 0, here we configure area 1, that's why we are getting this issue. And you can see here notification is coming mismatch area. And if you see neighborship will go down, you will not have the neighborship. If you see dead timer expire already here, you can see. And if you check here right show IP route, you will not have the route in the routing table. So this is the first troubleshooting you need to check, and you will observe this notification. If you are connected with the console, you will get this notification. If you do telnet or SSH, then you will not get, then you need to write terminal monitor. If you are not connected with the, if you are connected with the telnet or SSH, you need to write terminal monitor. Okay, so then only you can access that one. You need to write this one, because I am connected with the console. I am connected with the console, so it is giving me are already connected to console. But if you are accessing with the, what we can say, if you are accessing with the telnet or SSH, you need to write terminal monitor to see this log. So this log messages is coming, that is mismatch, area ID mismatch. So this is the first step. If you observe these log messages directly, you can check, you can write show IP OSPF interface brief. This command we will use to check whatever interface is configured and it is in which area. You can see we have two interface in this router R2, we have two interface, and one is configured in area 0, one is configured in area 1. So you can see this one is F0 by 0, F0 by 0, this one is configured in area 1. And if you go here and check here, you can write show IP OSPF interface brief, and you can see here we have two interface, one is physical interface, one is logical interface, and both are in the area 0. If you see this one, this interface in area 0, but if you see this interface is in area 1, so you have area mismatch. Both should be in the same area. If both are in different area, then it will not work. So how you can fix? You can change this area to 0, or you can change this area to 1. Means directly connected, whatever the link is directly connected, both should have the same area. If you don't have the same area, then it will not work. So here I will change the area. So how I will change? I will go to the interface F0 by 0, and then I will write here IP OSPF 1 area 0. Then it will start working. If you see that error message is also gone, and you have the neighborship back, and you can go here and check, you will have the neighborship, you will have the root. If you write show IP root, you will get the root after some time. If you write show IP OSPF neighbor, you have the neighbor entry. If you write show IP OSPF database, you will have the database table also. And if you write show IP root, you will get the root in the routing table. Now you can see you have the root here in the routing table. So first point what we done here, area mismatch. So if you are doing troubleshooting, you need to consider this point, area. We can put some points like requirement of OSPF or something we can write, like let me put here, we can say OSPF neighbor requirement as given below. So just now we changed the area and we observe. So what we can write here, we can write the device must be in same area. Directly connected device, we can say directly connected device. So you need to remember directly connected device must be in same area. Means this one both should be in same area, and here you can have any area this side, no problem. So this is first point we check just now. Now what we will do, we will check the something different. We can change the timer here. You can go here and change the timer, hello timer, dead timer. If we change the timer also, you will have the issue. So we can change and we can check. So how we can change, we can go here under the interface F0 by 0, and you can write IP OSPF and press question mark, and you have here option hello interval. You can see here this is a hello interval and this is a dead interval. So if the directly connected interface should have the same hello interval, so I will write IP OSPF hello interval. By default you have 10, I change as 20. If you have different hello timer, again you will not have the neighborship from here to here. Here I change 20, here you have by default 10. So neighborship will not form now. After some time you will have the issue again. Okay, after some time you will have the issue. How you can check the timer, you can write show IP OSPF interface F0 by 0, and you can check here timer we change here. What timer we change here, hello timer we change as a 20, and automatically 4 times more will be the dead timer. So you see here dead timer is 80, we change this, before it is 10. So whatever we change, 4 times of that one will be dead timer. And here if you see we have the issue, neighborship go down, neighborship go down here if you see this one. Why? Because we have the different timer. So we need to remember whenever we configure the OSPF, we should have the same timer. Directly connected link should have the same timer. In the real world we will not change the timer, but for troubleshooting purpose I am putting here. If you see here what timer you have hello timer is 10 second, dead timer is 40 second you have. Here you have hello timer is 10 second, dead timer is 40 second. But if you see here I change 20 and 80, that's why neighborship go down. And when you check show IP root, you will not have the root here. You are not learning anything with O here. And if I write here show IP OSPF neighbor, you can see we don't have any neighbor. If I write show IP OSPF database, you don't have, you will have the database table, but you don't have neighbor and you don't have root, because I changed the timer. So I need to go back to that interface and I need to return back to the timer. So I will write here IP OSPF hello interval. By default it is 10, so I change to 10. I change 10. After some time you will have the neighborship and it will start working. It will start working, and you see here it is started working here now. They form the neighborship. So what you need to remember, directly connected device should have the same hello timer and dead timer. If someone change the timer, then you will lose the neighborship. And you can see here now I am getting the root. So this is the second point. So whenever you are doing the troubleshooting, you need to remember this point. When you have the issue with the OSPF, you should consider like directly connected device must be in the same area. Directly connected device must have same hello timer and dead timer. This point you need to remember. Then third point we can say, what point we can give, like they should have same subnet. We can write directly connected device. This device must be in same subnet. This is compulsory. Without same subnet it will not work. So if you see here, what is the meaning of that one? Here you configure 12.1. If you configure here different subnet, because this is a class C IP and you can see /24 we have. So here and here should be same subnet or same network. If you put here different subnet, here different subnet, then it will not form the neighborship. Example, I will go here, I will change the IP interface F0 by 0. I will write here IP address 192.168.13. I will write, instead of 12 I will write 13.1, give space 255.255.255.0. okay, I change here, and you can see here already when I change the IP, neighborship go down. So this one directly connected device must be in the same subnet here and here. If we are considering these two only, this should be in the same subnet, and this one also directly connected. For R2 is directly connected here and here. So in this three place you should have the same subnet, but now we are focusing only R1 and R2. So this point is you need to remember. If you are getting the issue OSPF is not forming the neighborship, then you need to consider directly connected device must be in the same subnet here and here. I changed the different subnets, so you have the issue here. Neighborship go down. If you want to check, you can write do show IP root. You don't have the any root. If you write do show IP OSPF neighbor, you can see here neighbor table, nothing is coming. So now I will return back the same subnet what we have before. I will write 192.168.12.1, give space 255.255.255.0. then after some time it will be okay. Okay, after some time you can see neighborship will come up. You can see neighborship is come up. So this third point also you need to remember. First one we are saying device must be in the same area. Second point is hello timer, dead timer should be same, and the directly connected should be in the same area. And what else we can say? We can say here fourth point we can say, let me write here fourth point, we should not have the passive interface. Okay, we can say the device must be or must not be passive. The device must not be have passive on connected interface. So if we configure passive interface, then he will not involve in the OSPF. He will not send the OSPF updates. He will not receive OSPF update. So we will have the issue. So what we will do here, I will change here. I am here in the R1. I will go to this interface and I will change. What I need to change here? Passive interface. I will make that one as a passive interface. So how we will make the passive? I will write router OSPF 1. Then here passive interface. Which interface I want to make? This one, F0 by 0. F0 by 0. Okay, and press enter. So this way we can make the passive interface. You don't have passive interface concept, you have in the CCNP, but anyhow with this command we will enable the passive interface. Just you need to write router OSPF and whatever the process you are running. After that you will go inside this one, router OSPF 1. Then you need to write passive interface. Which interface you want to make passive? This one. So he will not send hello, he will not receive hello. So you can see the neighborship go down. So this is also another point. The device must not be in the passive on connected interface. So if you are doing the troubleshooting, you need to consider this point also. If someone make the interface as passive, then it will not work. So how I can remove? I can write here no passive interface F0 by 0, then it will remove and it will start working. Now you can see the neighborship go up, it will start working. So this fourth point is also finished. Now I can put one more point here. We can say here like fifth one, like the devices must have unique router ID. unique router ID. Already we know how to configure the router ID. Unique router ID means you should not have whatever you configure here. Here you have some different router ID. Here you should have some different router ID. Here everywhere should be different router ID. If you have same router ID, then they will not form the neighborship. Now I am considering only R1 and R2, so you consider only these two router. How you can check the router ID? You can write show IP protocol, and you can see here what is the router ID. Here in this R2, in the R1 you have 12.1, and if you go to R2 and check here, you write show IP protocol, you can check here. Here you have 23.1. Both are having different, that's why they form the neighborship. If I go here, example, if I go here, I will write router OSPF 1 and then router ID. If I give here 192.168, what we have 12.1. okay, I give whatever we have here, same router ID I give here. So when I give here, they are saying it will not change whatever router ID we have, you will have same router ID until you write here clear IP OSPF process command. Till we write this one, it will not change, you will have the same. So if you want to check, you can check, you have the same thing what you have before. So you need to write clear IP OSPF process, then click yes. It will reset the OSPF process. After that the router ID will change, and you can see here, if you write show IP protocol, you have the new router ID is 12.1, and here also if you see, here also you have 12.1. So if someone configure by mistake the same router ID, then you will have the issue, neighborship will not form, and you will get this syslog messages saying that one duplicate router ID detected here. And you can write here show IP route, you will not have the route in the routing table. So here how you can fix, you can write show IP protocol. Here you have this router ID 12.1, and other side also you can see the neighborship, everything go down here. And if you check here also 12.1. so this router both are having same router ID. The device must not have unique router ID. That is correct. The device must have unique router ID. But here what we have, here we don't have unique. Both are using same router ID. So what we will do, we will go here in the global configuration mode, we will write router OSPF 1, and then we will write router ID, and here you give some different number. So I will give here different, like 23.1 we have, so I return the old one, and then again I get this what we are getting. They are asking to reload the router or put this command. So I will put that command clear IP OSPF process, then I will say yes. Then it will reset, and you will have the new router ID whatever we configure here, and after that you have the route also here, you can see, and you can write show IP protocol, so you have the different router ID. So this point is also you need to consider. If OSPF neighborship is not forming, you need to check this also. The device must have the unique router ID. After that you have the device should have the unique router ID. Then we have 6 point, we can say, like the devices must have the same authentication configuration. If they have, then means if anyone enable the password here also you should have the same password. If someone configure here the password, here also you should have same password, else they will not form the neighborship. So if you want to enable the authentication, we can enable. There is one method. If you want to enable, you need to create the key chain. In that one you need to put the key, and you need to apply the authentication under the interface. So we can do that one. In the CCNP ENCOR we are doing that one, in ENCOR and in NRC authentication. In CCNA we are not doing, but anyhow I will show you that one also, no problem. What we can do here, this point we need to verify this one. If you have the different password, then it will not work, we need to verify that one. So this is a procedure. If you want to put that one, you need to create the key chain. So let me write here the configuration It is simple. You have the two types of authentication. We have the MD5, we have the plain text. We can use anything, but there is a procedure. If you want to put the password, first we need to create the keychain. We need to put the key in that one, and whatever key we put, we will apply here. So first what we will do, you will go in the global configuration mode, okay, and after that you will write here keychain, okay, keychain, and give the keychain name. I will give keychain name is Cisco. So it is created the keychain. You need to put the key. So I will give here key number. So I am using key 1. In the key 1 I need to put the password. So I will write key string. Password will be key string. So I am putting ABC. So what I done here, first, you don't have in CCNA. This is in CCNP, but in the we are doing the troubleshooting lab. So in real environment, if you face the issue, in real world, if you face the issue, OSPF neighborship is not forming, then you need to check this all points. So I am creating the problem, then I am showing, okay, you have this problem, that's why you are getting this type of issue, and we are fixing that problem. So here if you see, I created here a keychain. So if you want to put the authentication, you need to put password here. Then first you need to create the keychain. So you will go in the global configuration mode, then you will write keychain and give the any name to the keychain. So you are inside the keychain. Now you need to put the key. You write key and you need to give any number. So I give key 1. So now you are inside the key 1 now. So you need to put the password. So password, if you want to put, you can write key string, and any password you can write here. ABC I give here. So you created, you taken the keychain, you put one key and you assign the password. Now after that, what you can do, you can apply. Now you have this one interface F0 by 0. So you can go interface F0 by 0, and inside that interface first you need to enable. So you will write IP OSPF authentication message digest. So with this command I am saying I am using the MD5 authentication, message digest authentication. After that I need to apply. So I will write message digest key number 1 we have, and we are using MD5, and whatever the password we put the key, we will need to put that password. Here I put ABC inside the key, if you see. Okay, I put ABC. So we go under the interface. I enable here this authentication, and I give here the key. So I apply here. After some time you can see neighborship go down here, because here I put the password, here you don't have the password. That's why you have the neighborship will go down. So this is also one of the problem you will face. If someone enable the password one side and other side it is not enabled, neighborship will go down. Or maybe they will give the wrong password. One side they will give some different password, other side they will give some different password, then it will not work. So you need to do this one. So now I can do the same thing in the loopback also. Example, I have loopback 0. So I will go under the loopback 0. I can enable there also. So I will write this command in the loopback 0 under that one, and then I will enable the password also here. So when I press, it will be okay. Then I need to go here. I need to do same thing here. I need to create the key. So I will write key chain. I will write key chain. Any name I can give. I can give any name. I will give like Cisco. And key, I need to put key number 1. And key string I need to put same ABC, we need to give same. I am using ABC. After that, whatever the interface you have interface F0 by 0 dash, or you can write interface range F0 by 0, give space, comma, and you have F1 by 0. So I am enabling here also. Then I will write here, I need to enable IP OSPF authentication message digest IP OSPF IP OSPF, and then message digest key number 1 we are using, and MD5, and key we give ABC. So I applied these two interface, this one and this one. So here neighborship will go up, but here this will go down, because here we don't have any authentication in R3 and R4. So if you see, this neighborship go up from this side to this side, but other side neighborship go down here. If you see with this two router, you have this one, with this two router neighborship go down. So you need to go here again in the R3 and you need to do same thing. You need to create the key chain. So you write key chain and give the name, any name. I can give Cisco, then put the key inside that one, then put the key string, password should be same. I use ABC. Then you have interface F0 by 0, go under that one, write IP authentication, IP OSPF authentication we need to put, because we are giving to OSPF. IP OSPF authentication, message dash is IP OSPF, and then message dash and key number 1 and MD5 and ABC. Now it will form the neighborship here. It is formed here, you can see. Same thing you need to do here in 4 also. If you see R4 is also done, so you need to do the same thing. You will go here in the global configuration mode. You need to create the key chain. So you write key chain, any name you can give here. Cisco, and key should be 1, and key string we give as a key string ABC. So password will be ABC, and you have interface F0 by 0. We are doing inside this interface, this one. So here IP OSPF authentication, message dashes IP OSPF and message dashes key 1 we are using MD5, and key we give ABC. Okay, now it will form the neighborship. You can see both, you have neighborship from this side and you have neighborship from this side, both. So now you will have the root, show IP root. So you are getting the OSPF root, this one 1.1.1 and 12.2. so these both are coming. So we form the neighborship. So you need to remember this one. This is simple only. If you don't have authentication, no problem. But if someone enable one side and other side it is not enabled, then you will have the issue, neighborship will not form. So you need to cross check this one. And one more thing you have, let me add at last, because this one is asking all the time in the interview, like neighborship will be struck in Xstart. Why neighborship will struck in the Xstart? So we need to remember, if MTU maximum transmission unit is mismatch, then OSPF neighbors struck in Xstart. You need to remember this one. In interview you will get, in exam also you will get this one. MTU must be same on both neighbor. Else it will struck in Xstart. Okay, you need to remember this one. This point is very important. So whenever you are doing the troubleshooting, you need to check this all points. So now let's see. I will change the MTU here and we will check. So I am here in the interface. If you want, I will go interface F0 by 0. I will change here MTU IP MTU. I will write IP MTU. Here I will, by default you will have 1500. If you want, I will show you. Show IP interface F0 by 0. You can see here what you have. This is a MTU. Okay, 1500 by default. Both the side you will have same thing, but if I change IP MTU, I will put here 1400. Okay, by default you have 1500. I change here 1400. So if you write show IP interface F0 by 0, I change to 1400. You can see here it is 1400. But if you check here this side, what you have here, show IP interface F0 by 0, you can see here you have 1500. So we change. So you will have the problem now. Here is 1400, here is 1500. Now if you check show IP OSPF neighbor, neighbor will, after this timer finish, it will struck in X start, or we can write clear IP OSPF process. If you don't want to wait, do this one, it will reset. After that you will have the issue. You will notice neighbor will struck in the X start. Okay, so show IP OSPF neighbor. See here, neighbor is struck in X start. Before, if I did not do the clear IP OSPF process, I need to wait for some time. When this dead timer is finished, that time they will struck in X start. Now I do clear IP OSPF process, so it will reset, and after that we see it is struck in the X start. So in the interview you will get this question all the time for OSPF. If anyone is asking OSPF questions, they will ask you this question. This is compulsory question. If the neighbor is struck in X start, what is the issue? So see here, this one and this one both is struck here. If you check show IP OSPF neighbor, this 12, this one, I am here, I have 3 neighbor, one is this one is this, one is this. So if you see, it is struck in X start. What is the reason? If it is struck in X start, then you need to check the MTU. Okay, then you need to check the MTU. How you will check the MTU? You will write here show interface, whatever interface directly connected, you will write show IP interface. If you want to check the layer 2 feature, then you will write show interface F0 by 0. This is a layer 2 feature. This is a layer 2 feature, but we need to check the layer 3 feature. If you want to check the layer 2 feature, you will write show interface F0 by 0 is a layer 2 feature. So if you want to check the layer 3 feature, then what you need to write? You need to write show IP interface F0 by 0. You need to add IP, and see here we have MTU 1400, and if you write here also the layer 3 feature, show IP interface F0 by 0. You can see here you have 1500, here you have 1400. That's why the neighborship is struck in the X start. Okay, that's why the neighborship is struck in the X start. So what I can do, I can change, both should be same. So what I will do, I will go here interface F0 by 0, then I will write IP MTU 1500. Okay, and I will exit. I need to wait for some time, or show IP OSPF neighbor. If you see dead timer is also gone, you can wait, or write here clear IP OSPF process and write yes. Wait for some time, it will reset, and then you will have the neighborship up, because both the side I are just the same MTU. If I write show IP OSPF neighbor, we have the neighbor. Now they are in the init state. It will take some time, then they will do the all. Now it is in two-way state, like OSPF is having the state. Later we are going to see that one also. So it will go with the all state, and it will at last you will have the full state. So let's see here. Here if you see X start, you have here. So here also I can put clear IP OSPF process, clear IP OSPF, and without putting clear IP OSPF process only, it is up now, you can see. So if you want to do fast, you can write clear IP or wait for some time, then you will see. Now you can see the neighborship is in full. And go here and check here also, show IP OSPF neighbor, it is in full. So this is a troubleshooting step. You need to remember, this is a troubleshooting. First, what we can say, directly connected should be in the same area. Hello timer, dead timer should be same, and they should have the same subnet, and we should not have the passive interface, and router ID should be unique. And if someone put the password, all the routers should have the same password. And if MTU someone change, all the routers should have the same MTU. If we have the different MTU, then it will not work. So whenever you are facing the issue with the OSPF, because in the exam also they added 3 to 5 labs. In the CCNA exam they added 3 to 5 labs. So they will give you troubleshooting lab like this. So you need to check neighborship is not forming. So you need to check with this type of step, and you need to fix. In the olden days you don't have labs, they just give you theory, but now they added 3 to 5 labs, simple labs. You need to check like this basic thing. So remember this one. This point is very important in real exam and also in the lab also. In the real exam they will add you like if MTU is mismatch, what is the issue. In interview also you will get, in lab exam also you will get. So you need to practice whatever we are discussing in the class, you need to practice. Okay, so let me